Stateful workloads have a long life when deployed in a containerized environment. When a large telecommunications firm like Rakuten needed to figure out how to run databases, storage, message queues, and big data platforms, what were the challenges that they faced as they brought stateful applications on top of Kubernetes, managing deployments and lifecycle management? I got a chance to talk to Partha Seetala, who is the president of the cloud business unit at Rakuten Symphony and was previously the founder and CEO of Robin.io. Let's take a look.
Thanks, Bart, for having me. My name is Partha Seetala, and right now I'm the president of the cloud business unit at Rakuten Symphony. Prior to this, I was the founder and CEO of a Silicon Valley-based startup called Robin.io. And at Robin.io, we were focused on bringing stateful applications on top of Kubernetes and manage their deployment as well as manage the lifecycle management once they're deployed, given that stateful workloads have a very long life upon deployment in a containerized environment. We were acquired in April of 2022, last year, by Rakuten to support their 5G rollout within the Rakuten mobile network in Japan, as well as to supply software for other mobile operators who are rolling out their 5G and 4G networks in a cloud-native manner. That's my background.
Very good. Fantastic. With that in mind, looking at the particular case of someone in a company in telecommunications, what were the challenges that they were facing where they realized, we need to look more into folks that are specialized in running stateful workloads on Kubernetes. We need to expand our knowledge, our capacity. What were the, pain points that they were experiencing, and how did they decide, okay, we need to get into this?
Yeah. So, in terms of Rakuten, so you're essentially asking this question in terms of the Rakuten acquisition itself. Is that correct?
Yep.
Okay. So I think let me contextualize this problem statement a little bit, right? So Rakuten is a very large group of companies based out of Japan. In 2018, they got the license to a spectrum so that they can become a mobile operator within Japan. Now, just to kind of give background for folks who are not very familiar with this space. So typically when we look at, the evolution of mobile networks from 2G to 3G, from 3G to 4G, and now to 5G, one of the things that has always happened is that every such, jump up in the technology required big boxes to be shipped to closer to the cell antennas, and a new box for every new generation of, upgrade to the network. And you want more capacity, more boxes are shipped. Now, this is, of course, a problem for various different reasons, right? Number one is that the cost of just running a network is very high. The second thing is that managing the network when you have millions and millions of customers is fraught with performance problems as well as problems with scale. How do you manage so many boxes? How do you manage services running on so many boxes? So when Rakuten started this journey, they went about it in a radically different manner. So they basically said that if you look at enterprise customers, if you look at the adoption of cloud, it's primarily driven by softwareization, right? Everything can run as a software on commodity hardware. And because of that, you could essentially benefit from, of course, the cost compression that comes from commodity hardware, as well as the automation that you could do if everything is a software, right? Now, the obvious choice here is that if you're doing it as a software, what is the best format in which you can package these applications and then deploy it? So containers is a great platform. And then obvious next question is that how do you manage so many containers? Kubernetes is a great platform for that, right? So that is the background. So when Rakuten Mobile deployed their onboarded their network, they went about doing this using cloud native principles. Now, there are a couple of problems. Number one is when you are launching a network, you essentially have to handle state at two different layers. So actually, even before that, right, if you look at Kubernetes, the evolution of Kubernetes, the invention of Kubernetes was primarily for stateless workloads, right? Business logic workloads. You can basically spin up a container quickly. You can tear it down quickly. So you don't have to incur the cost of a VM boot up. You don't have to incur the resource consumptions from the hypervisor, any of those things. Right? It was essentially a very agile platform. But once that problem was solved by Kubernetes, the obvious next question is, you can never really have a truly stateless workload. every stateless workload is actually processing data. Either the data is streaming over the network, or the data is stored somewhere in some other database. Now, what that means is if you truly want to enjoy the agility benefits that Kubernetes or containers offers, you essentially have to think about this from an end-to-end stack perspective. You have to deploy the stateless components of your application stack as well as the stateful. Only when you do that would you be able to get the benefit of end-to-end agility as well as the end-to-end streamlining of your lifecycle management operations. Now, given that Kubernetes was designed to be stateless, how do you bring state into it? Yes. So there are, again, as I said, there are two types of state. When people talk about stateful, they only talk about it from the perspective of, storage heavy stateful, right? There's also a network state that is also as important, especially when you're, operating in the 5G network, 5G or 4G network. So now coming back to your question, right? So what is their interest and why would they work with a startup like Robin.io? So first of all, Rakuten realized that in order to run both stateful and stateless to get that agility benefit, they had to figure out how to run databases. They had to figure out how to run message queues. They had to figure out how to run big data platforms on top of a Kubernetes cluster. But not only that, they also have to figure out how to actually operate this at scale, because a 5G network is made up of literally tens and thousands of edge locations. Then they all aggregate these tens and thousands of edge locations where you have maybe between 3 to 100 or maybe 50 servers per edge location. All these tens and thousands of edge locations aggregate to hundreds or maybe thousands of near edge locations. You could call them regional data centers. And those hundreds to thousands of regional data centers where you might have upwards of let's say 100 servers, they all aggregate again to about 2 to 4 central data centers. Now, you have to not just think about how do you do stateful workloads on an individual Kubernetes cluster, but you also have to figure out how do you essentially stitch a service all the way from the far edge to the near edge to the central data center, and how do you preserve the flow of traffic from all these different layers, as well as figure out how do you handle things like healing. Do you heal within the same cluster? Do you heal across clusters? Right. So those are the kind of challenges that they had to solve, and that's where where we come in at Robin.io, because that is the innovation that we started out with. So we looked at the problem fundamentally different from the general notion of bringing stateful. We basically said, in order to bring stateful, we should solve both the network stateful as well as storage stateful. We have to handle stateful in the context of multiple Kubernetes clusters where different types of services are running, but they're talking to each other, right? So at a very high level, I think that's what I would say is what attracted Rakuten to us. Just to kind of give a little bit more context, we were acquired by them last year, but they were our customer in 2019. And once they started to see the benefits of what we had to offer, it went from being a customer to an investor, and from investor to essentially a company to an acquirer.
I think, because in our community, a strong focus is on end users. So it's interesting, that, Rakuten were end users and became so invested in that and seeing so much value in it that they decided to take, further steps. And I think it says a lot about the promise of what data on Kubernetes technologies have to offer. You mentioned a couple of things that have appeared in our research report. And I really like as well, too, because I have to be totally honest. We've had a few conversations about networking in our community, and we certainly need to have more. We can talk about that a little bit later. But one of the things as well is that when the community started out, the heavy focus was on database and storage and container attached storage and running databases like whether Cassandra or MongoDB on Kubernetes, the challenges and opportunities there. But you mentioned two other workloads. One can go even further. Messaging. So that's one that we saw in the research report of an increase of that arriving on the scene and becoming more active. What do you think about the possibilities, the things that are happening there that attract your attention and that you think will attract the attention of other organizations that are looking to become end users of data on Kubernetes technologies?
So actually, I will give you a little bit of my perspective in how customers need to think about stateful workloads. And let's for now just stick with, let's say, storage centric stateful workloads, right? When you say stateful workloads and storage centric stateful workloads, the very first question or very first thought that comes to anybody's mind, right? Anybody who's familiar with the space is, how do I take storage, make it available to containers or pods? And obviously, once you make it available, how do you ensure its resiliency when servers fail, disks fail, and so on? That is the very first thing that comes to anybody's mind, right? Now, contrary to all the vendors in our ecosystem who are essentially supplying software, including my own organization, right? I would say that problem for the most part is largely solved, and any vendor who says otherwise is actually not really being honest and truthful about it, right? If the problem were to be stated as, how do I give storage to pods and make it resilient to failures? And the industry has been running this for the last 30 years. The only thing that has changed here is containers, isn't it? Instead of giving it to bare metal servers or virtual machines, you're putting an application inside a container. So I think that is not the way, when customers look at stateful on Kubernetes, that's not the way they need to look at it. I think there's a fundamental difference here that needs to be appreciated, because it might not hurt the customer on the first deployment, but it might hurt them on an ongoing basis. So let me give you some perspective from my own personal, experience in this industry. So I've been, deeply involved with storage for almost 25 years now in my career. I was part of very early on in my career. I was part of a company called Veritas. Veritas was at one point in time the fifth largest software company. We built the industry's cutting edge enterprise grade storage way back when, right? And since then, I've seen the evolution of storage go from host-based storage, where one application was running on bare metal servers, and the storage is coming from a disk that was attached to the host, to array-based storage, where you had the companies like NetApp and so on became very popular, where you said storage needs to move away from the host into its own set of arrays, and it needs to be managed by storage admins and so on, right? And then we saw this evolution of virtualization come in and say, oh, you know what? The problems are now very different, because it's not just one bare metal server hitting this array. You have so many such virtual machines in the same physical server that are hammering this array, which means that you have issues like noisy neighbor. You have several other, there's an issue of scale and so on, right? Then we saw, that became very complicated. And then we saw the evolution of, technologies like HCI, which is hyperconvergent infrastructure. And the primary driver for that hyperconvergent infrastructure is that once you had a sufficiently large virtualization footprint, you had to figure out how do you converge at an infrastructure layer, storage, compute, virtualization, as well as networking, and then you also have to solve the problem of how do you make it accessible to somebody who's not experts in any of these things, right? Maybe it's just a virtualization expert who will be able to manage all these things. So HCI essentially brought in all these things and converged both from a technology perspective as well as from an operations perspective. Now started containers, right? So from HCI, we started to see, there's again a fundamental shift in technology where containers started to become very popular, and container orchestration platforms like Kubernetes started to emerge. Now, if you look at it, right, through this evolution that I just said, from host-based storage to array-based storage to storage that is optimized for virtualization workloads to HCI, every single time storage changed. Every single time the vendors and the architecture that was used to support storage for these workloads changed, right? From Veritas host-based file system to NetApp's array-based file system to when it came to virtualization, it was either Nutanix or even VMware's vSAN architecture, right? But when it came to containers, there are two fundamental things that have actually changed. And I'll tell you what those things are. But what I've observed is, the same storage vendors, obviously, right, from a business perspective, are peddling the same architectures and same products and saying, oh, because we are very good at storage, we just provide a CSI a hook into it, and you can just connect our arrays or whatever it might be into Kubernetes, and you're good to go. Now, to me, I think that's actually a very wrong way of looking at it, right? Now, what's the reason for that? So, for that, let me explain the two problems that actually exist when it comes to container-based storage. Number one is that applications themselves these days are not monoliths, right? I mean, even if you look at databases, right, you essentially have a distributed sharded database. I'll take MongoDB as an example. MongoDB is not just one pod, not one container. It has its own topology of different microservices, right? It has things like shards, replica sets. These replica sets are different from the Kubernetes replica sets. So it has shards, replica sets, config servers, query routers, and so on. And the database itself provides scalability through this horizontal sharding of data, which is partitioning of data. It provides resiliency because it basically says the way you need to place these different components on different hardware devices so that I can get the availability when one of those devices fails is built into the database itself, because it understands from in terms of query routing, in terms of data placement, it understands all those things, right? Now that is the world we are living in. Now, when you do something like that, the first question that needs to be asked is, okay, first of all, how do you understand these topology requirements and performance requirement that these distributed database require, and map it to the Kubernetes world? Because if you don't do it, and it just so happens that everything goes to the same server, the server dies, the database is essentially dead, right? So Kubernetes obviously solves this problem from a compute perspective. It has all the affinity, anti-affinity, and all those rules. But regardless of which storage vendor you use, the problem of figuring out the enforcement of the data placement alongside compute placement is a critical problem that needs to be solved. Because think about it this way, right? Let's say that you're running two pods. Each of those pods requires a volume, but each of the pods, through the anti-affinity rules, is running on two physically different servers, but the storage volumes are coming from each other's servers. So if in logical thinking, yes, if one of the server dies, you have access. But in physical terms, one of the server dies, the compute of it one dies, but the storage for the other guy dies too. So your essentially application availability is gone, right? Now this is a problem that needs to be solved. Forget about just storage availability and all that. If this problem is not solved, it becomes incredibly hard to actually support modern day workloads, right? And Kubernetes does not solve this problem, not even through CSI, because essentially this problem is solved when you solve the placement of compute alongside storage together, right? And this problem gets more and more complicated when your application size is very large. In fact, just to kind of, as an example, I'll give you this, right? Not just to talk more about Robin per se, but as an example, we had a fairly large deployment of a Cloudera cluster running on top of Robin and on Kubernetes, right? About 500 such nodes, right? When you have to plan for storage placement and compute placement for something like a 500 node cluster, it's incredibly hard, right? Because you essentially have to do an algorithmic placement of things so that you don't really have this mismatch of placement and so on, right? Of storage and compute. That problem needs to be solved. Now, there is a second associated problem. The second associated problem is who's managing these clusters? It's not a storage admin, right? It's not a virtualization admin. The role of managing these things now has fallen onto the DevOps engineer. The DevOps engineer is a generalist, right? They don't really understand the nuances of what it means to stripe data. They don't understand the meaning of what it means to snapshot data and all those things. So, how do you actually make storage accessible to this new type of user who is now burdened to manage this cluster? Is also a problem that needs to be solved, right? And CSI doesn't solve the problem, because what CSI does is CSI is a democratization of the different API sets, right, that each individual storage vendor supports into one common, API, if you will, which will allow storage to be connected to pods. The management still resides somewhat outside, because the management is still, the burden of it falls under the implementation of the storage itself. Because how do you do rebuilds when things fail? That's not what CSI does, right? How do you stripe the data so that you can provide performance and agility of failure and all that? That's not what CSI does, right? How do you do snapshots? So I think these are the problems when vendors are looking at picking a stateful, a storage vendor for running their stateful workloads. They have to ask these questions. How do you take your architecture of a storage stack that was built for the yesteryear applications and run it on this? because that is the day-to-day problem that they'll face. If I might expand, there's one more problem, right? Snapshots. What is a snapshot? You ask any storage engineer, I mean, they have been doing this for the last 30 years. Yeah. But in the context of a DevOps engineer snapshotting an application, they don't care about storage snapshots. They just want to create a point in time, a checkpoint of their entire application stack. But what is an application? Application is not just storage volumes, right? It's not the PVCs. It is the configuration, it is the metadata, and it is the PVC for your entire application. And the entire application could be a complex collection of Helm charts, not just one Helm chart, because you would like to checkpoint the entire thing. Now, when you are picking a vendor, that is what you need to ask for, right? How do I get a checkpoint for my application so that I can roll back in case there's a user error? How do I do a backup of my entire application, which constitutes its metadata, configuration, and data, so that I can roll it back into its pristine state when it's required? First of all, what is the problem if you don't do it that way? Let's say you have a database. You back up the storage volumes because your CSI vendor allows you to back it up. But the passwords for the database are not going to be stored in the storage volumes. They are stored in the secrets that come from a different place, right? When the pod is spun up. But if you don't back the secrets up, then even if you can restore your storage volumes, they have no use because the database essentially cannot open those storage volumes and read them, right? So I think the fundamental takeaway here is when a customer is looking at picking a storage vendor for their stateful workloads, storage-centric stateful workloads, they need to ask these questions, right? How is this new storage architecture lending itself for this complex placement requirements, the application level centricity when it comes to data management, and the accessibility so that generalists can manage this entire large farm of clusters.
Now, you mentioned the point as well about stakeholders, skill gaps, things like that. There's a question I'd like to drill down a little bit more. We've had conversations about people making the change from becoming DBA to SRE, but then also DevOps folks, or maybe ones more on the sysadmin side, all of a sudden finding themselves in positions where they're dealing with data. There's yet to be, of course, there are consultants out there who do trainings. There's no exact certification around this. What do you think organizations need to keep in mind as they face that challenge? How can we upskill our staff? Obviously, some things can be automated, but it's a very large landscape. It's a large ecosystem. What are things that you've seen worked in terms of tackling that problem?
I mean, I've seen a whole breadth of different things, right? I've seen organizations that have access to hiring from a talent pool, essentially build that skills within their organization. Either they upskill their existing employees or they hire for the special skills. But I've also seen, and I think I would say this is the more dominant observation, right? Or things that I've seen is where they would essentially outsource their entire problem to maybe an SI who would come in and handle this for them, right? Now, to your question of what is maybe what would be a right model for this, I would basically say that it has to be somewhere in between. Obviously, these are specialized skills if it's not implemented well. So you would have to have that the talent pool within. But we also have to be cognizant that not all geographies have access to that talent pool. That talent pool is very expensive, which brings us to the real point where I said that the architectures themselves, the product architectures themselves should lend it themselves well so that generalists with a little bit of training can essentially manage these clusters without going into the deeper understandings of the domain, right? Then, of course, you would also have a mix of a little bit of professional services or some kind of ASI work that will be required. And that is only required when you're operating at a massive scale, right? At a telco grade scale, for example, right? You would need that not just because of managing individual products, but onboarding of different vendors' application stacks might require some customization, or it might require some tuning or whatever, what have you, correct? But I think the way the industry should really aim for on two sides is number one, the customers should get some familiarity with it, not necessarily become experts. And the vendor supplying the software should essentially aim for simplifying it so that generalists can manage it. And that's where we need to be headed.
Fantastic. With that in mind, one of the things that was identified also in the research report as being one of the number one challenges, top challenges, is the difficulties around integration with existing tools. You've talked about, some of these systems, some of these technologies that have been around for a long time, and the difficulty of Kubernetes native, whether it's, that's an issue or not. What do you think about that? And what do you think needs to happen in order for integration with existing tools to not be in a top position in our research report?
Yeah, so this is always a challenge for any new technology, right? I mean, initially when a new technology comes out, I think each vendor will come up with their own set of APIs or tools, right? And over time, people will see that it's becoming very complicated when you want to integrate those tools or those workflows with the other set of tools, right? But that's the nature of innovation. The nature of innovation is that you don't start to democratize the API sets to begin with, right? Because innovation essentially, successful innovation solves specific customer challenges first, and then solves the problem of how do you make it seamless across the board, right? So typically what I've observed is that when a new technology comes in, it comes with its own set of tools, their own sets of APIs and whatnot. There is going to be siloed adoption of those APIs and tools. Over time, the community realizes that the fragmentation that this causes can essentially lead to higher implementation costs or complexities in terms of management. And the community rallies around creating a standardized API set. I mean, even if you look at storage, right, the CSI was basically a community-driven, if you will, initiative, so that even if each storage vendor had their own set of APIs, the way it would integrate with Kubernetes is now standardized, right? So I would basically say that while there is quite a bit of discussions around, how does this whole different set of tools come together, to me, it's a very natural evolution. You would see, I mean, next year when you talk about this, I'm pretty sure there'll be more standardization around the tools and standardization around workflows, right? People talk about GitOps, you'll start to see more and more vendors adopt that, right? But to begin with, I think it is also right that vendors don't do it, because first there has to be a baseline understanding of the new innovation that comes in the industry. Next should be a baseline, embracing of a common set of tooling and workflows, right? So I think we are going in the right direction, if you ask me. CSI is in the right direction. When CSI itself started, it started with just storage. Now there is a standardization around data management, like snapshots and so on, right? Going forward, there will be more standardization around performance metrics, how they are gathered, how they are published to standard observability frameworks and so on. So I think all this is going to happen, right? How does it integrate with GitOps and all that stuff, right? It's going to evolve and it's going to happen.
Very good. Lastly, we want to challenge the community to so that people are thinking about the right questions. What are questions that you feel are not being asked enough or should be asked more when it comes to the future of data on Kubernetes? What are the next frontiers or the areas where you would like to see more work happening or things that are yet to be resolved?
This is a loaded question, right? I mean, on one hand, you're asking what questions perhaps customers need to ask, right? And maybe the other question you're asking.
No, I'm saying around the technologies being used. What are the questions that you have that you feel have yet to be answered? The like would say the uncovered territory, the things you're like, if we could do this, why can't I do that? These kinds of questions.
Got it. Okay. So yeah, I think this is an important one, right? So I would basically say that now that the problem of running stateful workload on Kubernetes is well understood, now that we have a good number of players in the ecosystem that can solve that problem, varying degrees of efficiency and all that, I think the fundamental question that we should ask and we should address as vendors supplying into this thing is, where is the largest footprint of storage today in the application stack? And surprise, surprise, it is not in the newer age applications. There is still, whether you like it or not, there's still petabytes of old school applications that are very storage, intensive, right? Including things like Oracle RAC. That is where there is a massive footprint of data, right? The enterprise grade applications. and they are still struggling. Those problems still need to be solved. They might not be the most attractive, cool problems that people think about, but they are the problem that customers are grappling with. So the question here is that, okay, now that we have solved the problem for the newer class of workloads, now how do we extend this so that the older class of workloads also are brought into the fold of Kubernetes as well as stateful on Kubernetes? Because if you don't solve this problem, right, what would happen is that you're essentially creating a big silo, in the customer's environment where you essentially have one stack for old school, another stack for new school, right? And I think that's bad. As an industry, I think it's a bad thing. So as vendors are innovating, we need to look at all those things. We also need to look at other innovations that are happening on the hardware side, right? Whether it is phase change memory, what does it mean? Byte addressable storage, what does that mean, right? And we didn't touch upon this topic today, but what we have seen, our practical experience at Robin as well as at Rakuten, is there's other aspect to statefulness, which is on the network side. That has to be essentially accounted for when it comes to placement of pods and when it comes to healing when things fail, both at the network side as well as at the compute side. So how do we essentially innovate there would become the next set of challenges that need to be addressed.
Fantastic. Well, thank you very much for your time today. We will need to dive into that more in the future on the networking side, because like I said, I know there's a lot of important things that are happening there, and it's something as a community that we really need to incorporate more in the conversations that we're having. As a start, we began in a certain area, and now we've realized this ecosystem has expanded a lot, and we've seen that the results and responses in the research report. So as soon as we get other folks, or if you would like to bring other folks on as well too, to talk more about networking, I would love to get involved in that, because I think it's an area that definitely needs more attention in our community.
Thank you, Bart. It was a pleasure talking to you.
Likewise.